this is part 2 of your chapter 3AB notes. This is going to be specifically just on bow tie triangles versus hourglass triangles, and how would you know which one you want to use in the problem? Well, obviously it's going to be based on whatever your givens and unknowns are. What I'd like you guys to do is write this down, and you may want to do this on 2 bigger pieces of paper instead of just these small little squares. So let's draw our coordinate plane here. And on our coordinate plane, you know that you have north, east, south, and west. This is also known as your first quadrant, your second quadrant, your third quadrant, and your fourth quadrant. So we've got like our basics listed here. Now what we want to do is we want to draw 4 triangles that are going to be assessed as such that they form a bow tie when all meeting at the middle here. So theta is always going to be like at this dead center in this area here is where theta is ultimately going to end up. So looking at that, let's just look at the first quadrant and what the first quadrant is going to consist of. Oh darn. Where it comes to these triangles. Okay, so to draw your first triangle here, and you want theta to be at the center, right? You want theta to be in this area. Well, how are you going to create that? You're going to have to go east, and then you're going to go north. Now remember, from the first video, your theta is always drawn between the first vector and your resultant line. So there's theta right there for the first triangle. Now looking at this, what can you tell me about your x value, guys? Is your x value going to be positive, or is your x value going to be negative? Your x value should be positive, right? Because you're moving towards the right, you're moving towards the east. What about your y value? Your y value is going north, so it should also be positive. Okay, so looking at that then, if you have a positive x and a positive y, then you want to then assess how are you going to solve for your direction here. So if you have a first quadrant bow tie triangle, okay, let me say that one more time, a first quadrant bow tie triangle, the red that we just drew here, then how are you going to assess this? Well, what did you know going into it? You knew your x and your y components. Well, that is adjacent and hypotenuse, or excuse me, adjacent and opposite. We don't have a trig function out of SOHCAHTOA that shows you adjacent over hypotenuse, or, what I really mean to say, is adjacent over opposite. But you have one that's opposite over adjacent, right? And that's your tangent function. So very simply, what's going to happen here is that theta is going to equal the inverse tan of y over x. Theta is going to equal the inverse tan of y over x. And that's what you would use to solve for your direction. Magnitude is Pythagorean theorem. But this is the equation that you would use to solve for your direction. The sign on your x and your y components is extremely important because this is going to show you north of east versus south of east. So if you had a negative 7.7 degrees, for instance, and that would imply south, right? Okay, well, Miss Sartor, how do you know that you're calling it north of east and not east of north? I totally get that we were going east and we were going north at the same time, but which one do you write first? Okay, listen to this, please, because there's really not too much space in here to write this. The way that you know how to label these with your cardinal directions is you write the second vector's direction first. You write the second vector's direction first, followed by the first vector's direction. Okay, so which vector did you draw second? Did you draw east second, or did you draw north second? Well, you drew north second. So if you have a first quadrant bow tie triangle, what's your cardinal direction? How'd you move? Did you go east of north, or did you go north of east? Yeah, you went north of east, and stop and think about that. That literally is saying I went north of my eastern line, right? Because you first went east and then north, so you went north of your eastern line. So once you do this inverse tan, you're going to say so many degrees north of east will be your final answer there. Okay, let's jump over here to the second one. So we want theta to be in the dead center again. So we're going to first go west, and then we're going to go north, and then we're going to draw in our resultant line, placing theta at the center here. Okay, so for, well, y, what did you do? You moved positively. How about for x, though? You moved negatively. So once again, you know your x and your y. So the equation that you want to use for a second quadrant bow tie triangle, is still inverse tan of y over x. It's just this time odds are you're going to get some negative degrees coming out of it. Okay, so which vector did you draw second? Did you draw west second or did you draw north second? Well, you drew north second. So this one is going to be north of west. Make sense? Okay, let's move down to our next one. So for the third quadrant, you're going to go west, and then you're going to go south, and then you're going to draw in your resultant line, placing theta appropriately. Okay, so this is going to be theta equals inverse tan. Okay, you know that it's going to be y over x, right? Because you're seeing the trend here of, oh, okay, if I ever draw a bow tie triangle, regardless of which quadrant it's in, it's always going to be y over x. But what I need to remember is it's not just simply y over x, because that would mean only magnitude. This is specifically telling you about direction. So I need to imply the correct sign with my x and y quantities. So with that, that would mean that you moved negatively x, You moved negatively y divided by negatively x. Well, if that's how you move, guys, did you go west of south or did you go south of west? Okay, time out. You should be seeing a trend here. With your directions on bow tie triangles, you're always going to start with your vertical direction followed by your horizontal direction. So which direction is vertical here in the third quadrant? South is, right? So you're traveling south of west. South of west here. Starting to see this bow tie form. Okay, the fourth quadrant. You're going to go east and then you're going to go south. Draw in your resultant line, place theta appropriately. So this is going to be inverse tan of, and you know it's y over x, but let's apply our signs to it. What about your x, guys? X is positive. What about your y? Y is negative. Okay, so how are you traveling here? Which vector was drawn second? It was your south vector that was drawn second. So you're moving south of east if you draw a bow tie triangle in the fourth quadrant. So this is really, really designed to help you figure out what is my direction for this vector quantity. Once again, magnitude is just simply the Pythagorean theorem. X squared plus y squared equals r squared. Okay? So for direction, you need to use the inverse tan of opposite over adjacent. If you're using a bow tie triangle, your opposite over adjacent will be y over x. It will be y over x. You just need to apply the appropriate sign with the y and the appropriate sign with the x based on which quadrant you fell in. And then always remember, the second vector is the first direction that's written. So south of west versus west of south. Which way did you travel second? I traveled south second. So therefore, it's south of west. Okay, so there's your bow tie triangles in which your trig function is inverse tan is opposite over adjacent, whereas on every single one of these, according to theta, you went opposite and then you went adjacent. Okay, you went opposite and then you went adjacent. So let's flip to the next slide here now, and this next slide is going to show you guys your hourglass triangles, which you could pretty much assume all we're going to do is turn this thing on its side and we would see an hourglass. So once again, let's get our coordinate plane down. And we have east, we have south, we have west, we have north being assessed here. So for the first quadrant, we're going to first go north, and then we're going to go east, and we're going to draw in our resultant line, placing theta between the first vector and your resultant line. So we're still going to have theta equals the inverse tan, but stop for a second. You have opposite over adjacent. Who's opposite? Who is adjacent? Okay? So on each of these, you're going to have your x divided by your y, correct? Because your x is now adjacent, and your x is now opposite, and your y is now adjacent. Makes sense, right? So like we're literally just turning everything on its side. How would you label this one? Which vector direction did you head second? Did you head north second, or did you head east second? You headed north second. Sorry, you headed east second. So this is called east of north. East of north. Do you have a positive x? Yuppers. Do you have a positive y? Uh-huh. Okay, let's move on to the next one. You're going to go north first, and then you're going to go west. Then you're going to draw in your resultant line, placing theta appropriately. So you already know it's going to be inverse tan. Once again, guys, how do you know that it's going to be inverse tan? Because you're given your x and y components. Your x and y components are your opposites and adjacents. There's no mention of like quote-unquote resultant, i.e. hypothesis, in this problem. Okay, so which one is opposite over adjacent? That is x over y. But how is your x traveling? Negatively. How's your y traveling? Positively. Okay, don't forget those signs. What would this second quadrant be called? Name it. It'd be called west of north. West of north. Cool. Okay, let's go south. Let's go west. Let's draw in resultant, placing theta properly. So theta equals the inverse tan of opposite over adjacent. Opposite over adjacent. Once again, x over y. Your x is negative, your y is also negative. How are you traveling? Did you get that? West of south? Good. Okay. So now you're going to go south, and then you're going to go east. You're going to draw in your resultant. You're going to place theta properly. Once again, you know it's going to be the inverse tan of opposite over adjacent. Who's opposite? Who's adjacent? Opposite is x, adjacent is y. Whereas your x is positive, but your y is negative. This quadrant is going to be called east of south. That sounds funny, right? You don't really normally hear that, but there is such a thing as hourglass triangles. Okay, one other thing that I would like to throw in here at you guys is, if you have, actually, sorry, please go back to your bow tie triangle slide, okay? Go back to bow tie triangle. You need to put this little disclaimer in here. If you have an angle of 0, 90, 180, 270, or 360, treat that resultant line as a bow tie triangle. So once again, like what I'm trying to say is a cat runs 5 meters up a tree. What's its x and y components? Oh, its x is 0 because it doesn't move anywhere, left and right. Well, correct, but mathematically now prove that to me. So the way that you're going to do that is by treating it like a bow tie triangle, where x is going to be your cosine function and y will be your sine function. So just remember this. If you land on 0, 90, 180, 270, 360, treat it as a bow tie triangle when you're solving for your x and y components. Okay, so on this, we want to look at an example here of trying to solve for the magnitude by showing all of your work here. We're going to spruce this guy up a little bit, and we're going to call this A. We're going to call this B. We're going to call this, actually, we're not going to call it any of those things. We're going to call this Y. We're going to call this X. We're going to call this R. And that should make sense why, okay? So for this resultant here, we're going to know that we have our x of a positive 1.5 meters per second. We have a y value of 0.80 meters per second, both of which are positive. And you're trying to solve for your resultant in meters per second. What equation do you want to use? X squared plus y squared equals r squared. Get your calculators out. So really, we're just looking at the square root of x squared plus y squared equaling r. So in your calculators, we have 1.5 squared plus 0.80 squared equals. Put that in your calculators. 1.5 squared plus 0.80 squared. That should come out to be roughly 1.7. 2 sig figs in your final answer, so 1.7 meters per second equals your resultant. Okay, so look at this triangle that you just drew. Once again, you went this way, then you went that way, and you drew in your resultant. So you have your opposite and your adjacent. So is this an hourglass or is this a bow tie, guys? Check it out. Did you draw an hourglass or did you draw a bow tie? You drew an hourglass triangle. Okay? So since it was an hourglass triangle, you know that it's still going to be the inverse tan of opposite over adjacent. Opposite this time is your x value and adjacent is your y value. So that really gives you the inverse tan of 1.5 divided divided by 0.80. Sticking that in your calculator, making sure you were in degrees, not radians.